So, it was a big one. Anytime you're ready. So 25 years later, we're still remediating for the 250,000 barrels of crude spilled into the Gulf of Alaska. And the system will never fully recover. But ongoing efforts are to identify and protect lands that are going to optimize, I guess, to optimize the work that we've already put into to restoration. But how do you look at data across a scale and over an expanse and over such a time period and compare it kind of apples to apples here to there? It's tough to do. So anyways, where are we going? Right. So anyways, the general concept was to take the extent of the Exxon Valdez oil spill and consider it in terms of relative habitats based on GIS models extrapolated to 11 of these, what's projecting now, 11 of these simplified, modified, extrapolated kind of layers to represent the 31 injured species identified by the Exxon Valdez oil spill. Using geospatial methods and GIS is a great way to take marine and coastal layers and push them inland, right, which is much more useful for land conservation purposes. And you can also take GIS as a means to consider non-traditional data for ecological models. In this instance, you might say, look at native subsistence fisheries in terms of traditional knowledge or the needs of conservation partners as they apply to your study area, or even how far, say, the local yacht club travels day to day, in a boat for the potential for human use and other recreation purposes, and then put it all together in a kind of general prioritization model. As we're looking at the Exxon Valdez area here, this is zoomed into Prince William Sound and expanding on significant marine harvest areas. These are significant coastal wetlands as they apply to areas impacted by the oil spill, which are great habitats for conservation purposes, rich in biodiversity. Taking terrestrial wetlands as they connect to those systems, again, bumping it inland to features, in this case, that are coastal shore zones. Here, looking at areas that are traditional subsistence use areas, giving them geographical extent. Again, beyond just kind of the point densities that Fish and Game collects on where people are taking fish, and looking back over time and where native communities have traditionally used it. It's also important to always tie in, because the little land trust I was working for can't cover the whole oil spill region, which is larger than most states, the needs of conservation partners, and you can give geographical extent to those based in ecological analysis. Here, this is the extent where, again, like I was talking about yacht clubs, is they might use coastal and marine environments for recreation and the potential therein, considering, again, ongoing mitigation. So then it's also important to consider where your landscape exists relative to existing protected areas. For habitat efficiency, islands are not ideal. So how the whole prioritization occurred was taking these individual grid squares and presence or absence of those 11 criteria and overlaying this scoring grid, this raster grid, onto the whole thing. And the problems of scale and of data distribution across this huge area were resolved by breaking the landscape up into 5 distinct geostatistically significant data regions, and then within that comparing scores against each other, but then also scaling them up to compare and create a whole significant conservation prioritization landscape. In this way, we leveraged this model to, I guess before I left Alaska in July, to identify and protect 36,000 acres into a state park on Afognak Island, and create a new marine reserve off of the coast of Kodiak Island. So certainly work is ongoing, and there's no shortage of money. Was that 5 minutes? Yeah. All right. Thanks.